So strong relationship versus weak relationships. We did that in chapter number 2. Strong relationship is where the line between the two tables is a solid line. And with the weak relationship, the line is not a solid line. Yeah, this is a strong relationship, but technically it's not, but they just drew it that way. Anybody remembers now? This is how the weak relationship looks like. Well, no, Victor, weak can be in one-to-many or one-to-one as well. Oh, many-to-many has rather, when you split a many-to-many relationship, then you probably can come up with a strong relationship. And why is this a strong relationship? Because the foreign keys are actually primary keys as well. So if a foreign key is also a primary key, then two tables are connected in a strong relationship. If foreign key is just a foreign key and it's not a primary key, then the relationship is a weak relationship. And whenever we have many-to-many relationships, we try to break it down into two one-to-many relationships. Okay, so that's how far we came in chapter number 2. Chapter number 3 takes things further. But chapter number 3 works with the data, not at the model level, but at the data level. And it basically tells us that when you are gathering data that will eventually make its way into the table, you have to make sure that your table is really up to the par. It's really up to the level where data can be stored, managed, maintained without getting broken. And without getting overwhelming, without getting difficult to query. So it's part of the design phase that earlier on, you should start looking into how your data is currently stored. Because a lot of the time when you take the data from an Excel spreadsheet and you try to go to an actual database table, things don't align 100%. So normalization is a process that helps you align the data better. So first of all, we look at the table and how the data is currently stored in the table, and we check to see, okay, these are the first normal form rules. Does the table data adheres to the first normal form rules? If it does, then we check to see if it adheres to the second normal form. Any normal form the data is in violation of, then we start modifying the data. And sometimes when we say modify the data, we may end up creating additional tables. We may end up creating additional fields. The whole idea is to be able to store data efficiently. Typically, databases would not go past the third normal form. Rarely you will see fourth normal form or fifth normal form or Boy Scout normal form. But typically, tables are normalized in 99% of the cases in third or second normal form. So now normalization mainly has two purposes. Number one, eliminate redundant data. And number two, ensure that data within a table are related. Okay. Oh, I just saw Francisco's question. I did not see it earlier. Okay, so strong relationship is dependent on parent. Well, let me rather put it this way, that strong relationship is when two tables dependency is higher on primary key level. So it's not really a parent-child relationship to that extent, but yeah, you can say that to some extent, because in some query by examples, primary key table is called a parent table. So when the child table and parent table have the same primary keys or partially same primary keys, then the dependency is stronger. Otherwise, the dependency is weaker. Okay. Having said that, since Francisco asked that question, and Francisco needs to be marked present now that he's here. So now everybody's here. Okay, cool. Okay, so eliminate redundant data and ensure that data within a table are related. That's basically the whole thing. So we have mainly three normal forms. Let's have a look at what these normal forms rules are. First normal form has three rules. Rule number one, that the data should actually be in a tabular form, in a two-dimensional table form. Rule number two, that you should not have any repeating groups. Each column can contain only a single value. For example, if you have an Excel spreadsheet and you're storing data about your clients and you have a phone number field and you start listing all the possible phone numbers of the person in one cell, now that is called repeating groups. You should not do that when it comes to databases. Maybe okay for an Excel spreadsheet. Then primary key must be identified. Second normal form ensures that the table must already be in first normal form. And then on top of that, there should not be any partial dependencies. What exactly does that mean? That means, let's say if you have like 10 fields, and out of 10 fields, 4 fields are dependent on one key and the other 4 are dependent on another key. So that's partial dependency. You're better off creating 2 tables then. Because if not all the fields are dependent on the primary key, that means it's not a good table. What do we mean by dependent on? For example, if you're storing information about customer and within that table, you also have information about departments or states or something like that, which is not directly related to customer, then you're better off breaking it up into 2 separate tables. Third normal form says that the table must already be in second normal form, and a non-key columns cannot be dependent on any other non-key columns. So there should not be a transitive dependency, like a column is dependent on a column and that column is dependent on the primary key. So you need to identify that and eliminate that. So as we start seeing examples of each one of these, things might get a little bit more clear. And then Boy Scout normal form, which is sometimes called 3.5 normal form, is that every determinant in a table is a candidate key. If there's only one candidate key, third normal form and Boy Scout normal form are the same. So for multiple candidate keys, you are in the Boy Scout normal form. Now, let's have a look at some of the rules here that in figure 3.2, which is this one, the 2 tables are in the table form. And we have capitalized the entity names at the bottom of the table. And we have bold and underlined the primary keys. And we have italicized the foreign keys. So that's basically, it's showing you that eventually this is what you will see in the rest of the book. And this is how you can visually see what is what. Okay. Okay. Now, this would be called a relational schema of the same idea, because this simply doesn't include the data. It has the entity name, the primary key, and the foreign keys and other keys. Now, let's hold a second. Let's look at this table, for example, here. Okay. Do you think, is this table normalized?
No.
No. Without seeing what it says at the bottom of the picture caption, why would you say, why is this not normalized?
Because it has 2 like data in the top row.
Yeah, so some of the records have multi-valued fields. Okay, what else? It is, oh yeah, also the warehouse ID is multi-valued. Yes. City is multi-valued, quantity, bin, state, zip, all there are several multi-valued fields. Okay, what else? Why is this not in first normal form? Is this in tabular form?
No.
Is it not in table form right now? I mean, like table means
Sorry.
two-dimensional.
I
Yeah.
thought you meant tabbed. Sorry.
Oh no.
Yeah.
So it follows one rule, but it breaks the second rule. And what's the third rule of first normal form?
Primary key.
Primary
being
key. And
Yeah.
we don't see any primary key. So we certainly can easily see that this is not normalized. So as we start normalizing this, what we can do is we can say, okay, let's create product ID as a primary key, but then we'll run into a problem because we have a product ID 167 in multiple warehouses. So if I start putting this in two different record sets, I could not put the same product ID for each record because primary key cannot be duplicated. However, the thing is this, that shovel is product ID 167, doesn't matter which warehouse it is in. So the only solution to the problem would be to create a candidate key where we do a combination of a product ID and a warehouse ID. We create both of them as a primary key. When you have multiple fields as primary keys, then the combination of the two values should be unique. So individually, you don't look at anymore. So 167, 111 is one combination and 167, 222 is another combination. So they are unique. Does everybody follow that?
Yeah.
Okay. So that's how we were able to solve the problem of removing the redundant data. We were able to bring in a primary key. Rather, we took it to a composite key level. And that's how we fixed the problem. So the table is in first normal form. Problem solved. Now, this is a better arrangement of the same table. We just pushed all the primary keys in the front and all the other keys afterwards. And you see there is a relational schema at the bottom where you list all your keys first and then non-key fields. So now let's see if this table is in second normal form or not. The second normal form says, rule number 1, the table has to be in the first normal form, right? And then there should not be any partial dependencies. Those are the only two rules to look at. Are there any partial dependencies right now in this table?
By partial dependencies, do you mean like between the two keys?
By partial dependencies, we mean that all the data that I have in the non-key fields, is that related to each of the key fields, or is it only related to the combination?
Okay, gotcha.
Okay, so we see that it is not related to each one of them. It's only related to the combination because if we look at the remaining non-key fields, some of the fields are only dependent on the warehouse ID and some are only dependent on the product ID. For example, warehouse address has nothing to do with product. It's related with warehouse. The quantity on hand has nothing to do with the warehouse. It's about the product. So that's called a partial dependency. When there's a partial dependency on one key, then you are better off breaking that up into multiple tables. So we created one table with a product ID and a product description. So that goes in one table. And then we have a warehouse ID and the warehouse information in another table. Now comes the question, okay, so then what should happen to the quantities and other things? So the thing is this, that the quantities and the other thing, that is your inventory information. That's not a product information. That's not your warehouse information. So we created a separate inventory table. And in inventory table, we created a combination of a warehouse ID and a product ID. They're both foreign keys to the respective tables, but their combination is a primary key. So that's how we are uniquely identifying each record. So if I want to know that product ID 167 is found in which warehouses, I could query that inventory table, and the inventory table can then see, oh, okay, it's found in warehouse ID 111 and 222. So what are those warehouses? Then I can go to the warehouse table and grab the addresses of those warehouses. So that serves as my intermediary table for both product information and warehouse information. And my product information table is just unique product IDs. So this would be a good solution for anybody who wants to store multiple products in different warehouses across the corporation. So they could have a separate unique product IDs, they could have a separate warehouse information, and they can have an intermediary table which links both of the other tables. Okay. Do you see something like this? If you look, let's say if you go to target.com and you type in the name of a product and they ask you to pick a location, and they can tell you that if they have that item in stock or not, right?
Yeah, definitely.
And
Not
then
accurately.
sometimes, yeah, because, you know, sometimes they can't really do it accurately for two reasons. Number one, the item could be in people's cart and it's not yet checked out. The second reason could be sometimes people pick items from the aisles, but they just put them wherever they feel like if they don't want it. They don't go back to the aisle and return it. So it could be somewhere in the store, but it's just not in the right place.
Don't forget about theft.
And then there's theft also. Yes, theft also is one of the factors. Absolutely. Absolutely. So there could be several reasons for that they're unable to. I mean, I happened to go to this one store in Canada, and we were about to purchase a thermos. I luckily opened the box, and everything was in place except for the lid. Maybe
Oh,
somebody.
that would be so frustrating. Oh my gosh. I'm glad you checked it.
Yeah, yeah.
Or
And-
the people who have different size feet but don't want to pay for special shoes, they'll take one from each size and then put the other inside the other box and just put it back on the shelf.
Ugh. Wow. Maybe there should be an app for people with different shoe sizes, and then you can pair those people, you know, I mean, like who can
With
actually,
people.
yeah.
Yes, I know where you're going with this. They could like trace the other half of the shoe.
Yeah, exactly.
Hey, we just need to normalize big size shoes before we start giving people different size shoes. I can't go to a mall and buy shoes because I can't find 15s anywhere.
I hear you. My husband is a 14. We have that same issue.
Yes.
Wow. I think they go like till 13 in most stores.
Yeah, typically.
Like 12 or 13 is what he's run into.
Wow.
Size 14, huh? If he stands on a sidewalk, do they try to give him a ticket for them size of foot?
Ah.
Oh, you guys gonna get it, all right? It's right over your head. It's all right.
Anyway, so I mean, I'm pretty sure a lot of the athletes, especially the basketball players, they have, you know, bigger feet, like shoe sizes, and they purchase theirs from these specialty stores.
Oh yeah, you go to Rogan's and you can find like size 22 shoes, but they're all basketball shoes typically. And that's just not my style.
Oh, okay. And you know, I have difficulty finding shoes because my feet is very narrow. And most men's shoes are wide. I mean, like even the normal ones are wide for me.
Wow.
So yeah, and then you know, I have to make sure I have the arch problem too. So I have to make sure it doesn't has heel in it. So it's like, yeah, it's sometimes it gets really, really difficult. Once I am comfortable in a shoe, I prefer not to change the brand or the style unless they stop making it and I have to go and then find something else.
Yeah, I haven't found that magical shoe yet.
Yeah. Dress shoes size 20, I'm pretty sure they probably would be making for these guys who are millionaires, right? These basketball players.
Josh, I know that you're probably not going to want to hear this, but my husband swears by cowboy boots. He said they're the most versatile, comfortable, they fit him great. So I don't know if that's your style, but apparently that's
I'm more of a moccasin person. I lounge all.
I feel you. I do. But yeah. So just there you go.
For a
Thank you.
moment, I was imagining Josh in the cowboy hat
I know.
and a rope.
All right. At the conference, going country.
Yeah, and then
I was
like
about to say
Josh.
we should just bring it to you at the conference.
Oh my God. Josh, what are you catching? I'm catching bites. Oh, anyway. Okay, so referential integrity is the next concept. The referential integrity concept is where the foreign key is forced to have only those values that can be found in the primary key. You cannot have a value in the foreign key that's not in the primary key. So that forcing is called the referential integrity. So if you try putting a value in a foreign key field and the system complains back and says you are in referential integrity violation, that's exactly what it means. You're trying to put a value in foreign key that doesn't has a matching value in the primary key. So foreign keys can have duplicates, but can't have a value outside the domain of the primary key. Okay. Now, one second here. Third normal form. Okay. In the third normal form, we need to make sure that the table is already in the second normal form, and there should not be a transitive dependency. A transitive dependency is that some of the non-key fields are actually dependent on another non-key field, and that field is dependent on the primary key. So for example, in the warehouse table down below here, the address is the city and the state are defined by the zip code, and the zip code is basically the warehouse locator. So in that case, you probably may split things on zip code. So that's basically how transitive dependencies would allow these tables to be split into tables. Now, consider this example. This is another example of a transitive dependency problem. What's the problem here?
There's two of the same customer number. Or I guess that's not a key field, is it?
No, it's not. It's not a key field. No.
All right.
Is it because you can calculate total amount from quantity and unit price?
Absolutely. That is the case. That is it. You got it. So anything that can be calculated does not need to be stored. Okay. So you can simply eliminate that column and you'll be just fine. The Boy Scout normal form is that if every determinant is a candidate key. So the Boy Scout normal form was developed to handle situations in which a non-key column determines the value of part of the primary key. So here the author goes about giving you an example of a patient number, appointment date, appointment time, doctor number, room number. Everything together can uniquely create probably some kind of a record set, but individually, you can't really do that. What if the same patient comes back multiple times in a day on the same date? So the appointment time factor could actually be used to distinguish one thing from the other. So that's basically talk about that anomaly here. So divides it up into one combination as patient number, appointment date, appointment time, doctor number. And the other one could be the doctor number, the appointment date, and the room number. And that's for the doctor, how to place a doctor in a room and how to put a patient in a room by appointment. So similarly, the fourth normal form comes into place that if the table is already in third normal form and it has no multi-value dependencies. However, a multi-valued fact is here in this particular case, that there are some data sets that are empty. So for example, for the same records, you have one column with a value and another column, it doesn't have anything. So for example, in this case, every employee has a child, presumably, right? But not every employee will have a child in reality. And every employee is forced to take a course, but there may be a case where employee has not taken a course. It's also quite possible that you're forcing employee to take as many courses as the number of kids they have, or the number of kids should match the number of courses. So that's why this is a failure. So that's why you're better off dividing this into two separate tables where you have one with employee child combination as a unique, and the other one as employee course combination as a unique combination. Again, very rarely you will see a fourth normal form problems. Okay, with this, I would like all of you to go over the practical example that starts from page number 12, from the bottom of page 12, and goes all the way to page number 15. So go over this example and give me a green check when you guys are done going over this example. Left. Everybody else is done. Okay. So for those of you who are done, do you have any questions? About the practical example?
Actually, yes.
Okay.
So let me scroll back to it.
Which page?
So 14 for the book page number. So one more down.
Okay.
All right. So they're going over why these are 2NF. And it says there are no partial dependencies. I guess I don't know if I'm getting it confused, but like the second table on the right-hand side with the student number, course number, and grade, wouldn't that kind of be dependent on like partially related, like you would need both of oh, it's because you need both of them. Okay, I got it.
Yeah, it's a foreign key there. Yeah.
Gotcha. Sorry, it's going to take time for that to kind of sink in. I think I overthink it.
No problem. Anybody else has any questions about this? Okay, what I would like you to do is go to the Blackboard. And in Blackboard, go to course documents. In course documents, you will find your second folder from the top that reads normalization. Click on that. Once you click on normalization, I would like you guys to click on this example of normalization PowerPoint. Go through that. Go through the normalization example 1. It's an Excel spreadsheet in which the normalization steps are done with another example. And then watch this video. Once you are done with these, then I will put you guys in groups, and then you will solve normalization problems that you will be given something that won't be normalized, and you would have to normalize it. And then you come back, and then we'll look at a solution, and then we will put you in a different group and send you back to solve another problem. And then you come back, we discuss the solution, and then we'll put you in a different group and send you back for the third time where you solve a problem and come back and we'll discuss. So first, review these 3 items, and then we will start the group activity. Is everybody clear on that? Where to find it?
Yep.
Okay, so I'll stop sharing and I will pause the recording. So I'm going to start sharing once everybody give me a green check that you have reviewed these items. And let me share the screen again with you guys. As you can see on the screen that I'm sharing with you, that inside the same button, if you refresh, a new item is available to you called normalization exercises. If you go down in the exercises, I've made only the exercise 1 available to you right now for you to work with in your group. So what you are doing is you are downloading the Word document, you're opening the Word document, and then you are normalizing this unnormalized data set. So you will check on every step to see if it adheres to the rules of first normal form. If it does, then you see if it goes into the second normal form. If it does, then you see if it goes into third normal form. It is quite possible that second normal form will solve the problem and you wouldn't even have to go into the third normal form. And then while you're taking it from one normal form to the other, you may see that you may have to create more tables and stuff like that. You know, I mean, like it's just a playground activity. So probably the first exercise, you may find it a little bit more difficult, but then, you know, when you come back and we get to discuss this, then you probably will be in a better position to go and do the second one. Okay. So you will be in your breakout room for 15 minutes to solve the exercise 1. And I'm opening your rooms now.
Yeah, for me, the issue was I got like the procedure number and the procedure name stuck in my head as one thing.
Oh, okay. As opposed to 2 separate data values.
Yeah.
Okay, so now what I will do, just give me 1 minute. I will open up another exercise and I will also create a different breakout room here than what we had in the first case. Jessica, who are you working with right now? And
I was just working with Robert Reed.
Okay, okay. Okay, so the second exercise is open, and I'm opening the rooms right now. Okay, guys, so how did it go this time?
A little better.
A little better. Okay,
Yeah,
I
a little
struggled more
better.
with this one.
cool, awesome. Let's have a look at the solution to see how this can be solved. Looking at the data set, let me call this one invoice. And let me start first of all listing all the fields we have here. So we have got the invoice number. We have got the invoice date. We have got the customer name. We have got the customer address. And we have got, okay, we have got the pets. But the problem is that all of these things are singular and the pets information is multiple. Okay, so that's unnormalized form. So if I were to take this to the first normal form, that will be a very easy division that I will have something called an invoice. There'll be one set of table. And then.
Question,
Yeah, go
real
ahead.
quick.
Mhm.
Would you, so I know that you said if it can be calculated, it's not going to be like a field, but would you put the tax as a field?
No, these things are done at the application level.
Okay,
Yeah, so we don't need to store them in database. Okay, so so invoice will be one of my tables, which will have invoice number and invoice date and customer name and customer address. That could easily go in one table, and I could have an invoice underscore pet table in which I can put the other sets of information which I have. However, in the first one, it's an easy thing that I can easily identify this to be my primary key invoice number. But the second one, I can't really have anything right now to be called a primary key. So what should I do? I can't have pet name as a primary key or procedure name or amount.
Well, we actually give the pets the pet ID, so
Okay, so we give pet a pet ID, right?
then that's the
Okay.
primary key.
That is that the sole primary key? We or
And you add the date.
remember, there must be a way for me to connect invoice pet with invoice, so that I know.
Invoice number?
Right, so it needs to have an invoice number, but will invoice number just be a foreign key, or will be also a primary key?
I think it's also primary key.
It's also a primary key because the same pet ID could be multiple times on the same invoice. So that's why a combination of them could be a first normal form. Okay. Now, I don't worry about partial dependency right now because partial dependency is dealt with in the second normal form. So when I look at the invoice table, I don't really see any partial dependency because there is only one primary key. So there can't be a partial dependency with one primary key. The tables that have multiple primary keys are the only tables where you look for partial dependencies. So when you start looking at the invoice pet table, which field in the invoice pet is partially dependent?
The pet name.
Amount.
The pet name. The pet name is partially dependent on pet ID rather than dependent on invoice. So we can have a pet table separated out like that. Okay, so we can have something like this for the second normal form. Oops, I messed it up. Put it in the wrong place. Okay. So that's my second normal form. Okay. Now let's get to the third normal form. So the first table, which is invoice number, invoice date, customer name, and customer address, that seems to be in violation of the third normal form because the customer information is dependent on customer, not invoice. So that is a table that really needs to be split. These two tables can stay the way they are. So we will just carry them forward the way they are. But invoice table needs some kind of a division. And we need to have a customer table with the customer information. Now, the problem is, I can easily move this information in the customer table, but name is not a good representation of a unique customer. So I may have to add a customer number to uniquely identify each customer because names are never good as unique identifiers. Okay. And then how will I link the invoice and the customer? Through the customer number, which will now serve like a foreign key, so I can italicize it like that. Okay. If I go back to my data set and look at my data set, the customer address is actually a multi-valued field. So I could break this up into maybe customer street, customer city. This will make it much easier for me when I'm querying the database. Okay. Now, what is this last field?
A zip code?
No, it's not. Zip codes don't have letters. Come on, Jessica, you shouldn't say
In
that.
Ontario, they do. I really did have to mail something to Ontario, and I just thought that was the zip code.
That's called the postal code. Ha!
Okay. Well, potato,
Okay.
potato.
When you're under the Queen, you got to act like a British. So that basically will do it. Right?
Couldn't you separate out procedure and amount?
Procedure and amount are both part of the invoice. There is no procedure number in this particular normalization table. We had a procedure number in the previous one, so we were able to split that.
Okay.
I see. Okay, I think you just answered my question too, because we did break down into a procedure table too, because we were like, okay, so it's, you know, in our eyes, we thought it was like partially dependent on like, because the procedure amount or the procedure, you know, the name of it or the amount, you know, would be the same amount, to, you know, more or less. But I guess it isn't. Yeah. So, okay.
Okay. Okay, just 1 second here, and let me do a couple things here. You know what? Let's take a break. Let's take a break till 7:50. So when you come back from the break at 7:50, in the meanwhile, I will rearrange the group and everything. So I'll see you guys at 7:50. So let's start looking at the document right now. So looking at the document in the unnormalized form, let me zoom in a little bit here. Unnormalized form. So we have some information about, in this particular case, about
Customer history.
Say again?
Customer history.
Yeah, so it's customer information. So let me first write down the unnormalized form about customer. And we got the customer number. We got the customer name. We got the customer address. We got the customer phone. And then we have some multi-valued information about the artist. So we got an artist ID. We got an artist name.
Are we just making the customer number column? Because I don't see
Yeah, I
one.
think so. Yeah, we are
Yeah,
making it
yeah,
because the
yeah.
name is not enough for the unique.
Exactly, exactly. So we have an art title, and we got
Price.
the purchase date and the price, right? So we got the purchase date and we got the price. Okay, so that completes the unnormalized form. In the first normal form, of course, it's so easy that you probably will have a customer table with the customer information, and then you will have a customer art table with the customer art information. That was a much easier process. So we're going to have customer information, and we'll have the customer number as a primary key. And in the art one, let me first move all this information in the art. Remember, this is customer's art. It's not the artist table right now in the first normal form. And we also need to join the customer table with the customer art table so that we know. So we're going to just put customer number there. However, customer number cannot be the primary key by itself. because the same customer could be making multiple purchases, right? So we could probably make a combination of a customer number and an artist ID. That could be a, or is it artist ID? No, hold a second. Yeah, but hold a second, let me think about it. So you have artist ID, artist name. The problem is that the artist ID and artist name are repeating, right? So you can't really have artist ID there as well.
Well, if it was a
So-
full list, couldn't an artist name actually repeat?
Well, the thing is that the key should be chosen for the repeating group. Let me think. Because the same piece of art could be purchased by the customer multiple times. By making that art number, like artist info, a primary key combination will not make it unique. If the customer comes back and purchases the same artist thing again, then you won't be able to uniquely define it.
Ah, okay.
Okay, so we probably can have an art code added for each purchase differently for the same artist, same art. And then we can uniquely identify that further by maybe combining it with a purchase. Purchase date. So to make the rows unique. Now, looking at these tables from the second normal form perspective, is the first table in the second normal form with one primary key? Yes, it is. But looking at the second table, no. The second table has two sets of information. It has the customer art information, and it also has the actual art information, which is uniquely identified by the art code. So we have art code, artist ID, artist name, art title. All of that information is related to the art. And for the customer information, we will have the customer, we will have the art code, which will be, oops, not a primary key though, because primary key is customer number. We'll have the customer number, the art code, the purchase date, and the price. However, we would still have to keep this unique. The combination will be what we're going to make it unique.
So how long did it take you to feel comfortable with this concept? I'm curious, honestly. This is like got to be very hard to teach to others.
I think it is too, because it's hard for me to understand.
Yeah.
Right, like I see.
No,
it
like
after
the thing is, when we were doing it on our own, right? We think that we were doing it right, but when you do it like so different ways. So, and then like when you just start doing it, we realize that we didn't do it right. So I don't know. I don't know how we're gonna like learn and start doing it right.
And maybe it's not that we're doing it wrong. It's that there are so many different ways you could possibly do it.
Yeah,
bas-
but the
bas-
thing is,
Mhm.
but the thing is, like, there's so many different ways, right? But if you just look at what he did and what we did, it's like different. So,
That's fair. That is very true.
so like what he did is the best possible way to do it, right? So basically, what we're doing is like we're still doing it wrong.
Yeah, you're right. Yep, you're right.
Well, basically, the thing is that you try to look at it from all perspectives as to that you are not missing any information. That's one perspective. The other perspective is, in long run, will this cause any conflict?
Do you have a recording on? Because you know,
Yeah, yeah.
Yeah, recording is on. Recording is
because
on.
I'm gonna rewatch these videos and try to see your pattern because it's I think we're missing the pattern. That's what it is. If you mess up on the pattern of how you're trying to solve these problems, it becomes hard and difficult. Like what they said right now is like we feel like your way is like the best possible way, and
And
Well, I feel like you-
normalization is difficult. Normalization is not easy. I know I went to a state called meeting in Madison a few years ago, and one of the state colleges instructor flat out told that we just don't teach normalization. I said, how come? It's an important component. He said, because that's too difficult for students. I'm like, really? Just because it's difficult, you're not going to teach it? They said, yeah, we don't have it. Wow.
I feel like they should teach it more to like get people used to seeing it more often. You know what I mean? Because this is going to take time to like get good at and practice. I feel like
So
doing their students a disservice, honestly.
I know,
What-
that's what I
what
was
they
like.
expect is like they think they would just learn by doing it at the job.
I don't know. I don't know what was irrational. I just didn't dig deeper into it because it was not my college, not my program, not my concern. I just asked them, and like, they told me flat out, we just don't. Because it's too difficult. Okay.
I feel like it's kind of, we're in a different mindset than what we really need to right now to focus on what the process.
So, yeah, I mean, again, the more you get exposed to the data sets, the more you start looking at the breakdowns, the examples, the more you get a hang of it. And then, again, as we said earlier, there is no right answer or wrong answer in a way. But the bottom line is that you got to make sure that you are covering all your bases. And that could only be done if you have enough. For example, in systems analysis and design, we're learning about requirements gathering. And that's exactly plays a very important role when somebody's preparing this document. And this is a good example of, let's say somebody comes to me and say, okay, this is my invoice for workplace. How can I store this? Right now, we're doing everything on paper, or we're doing everything in Excel worksheet. So this would be a good way, a good exercise to grab a piece of invoice and try to figure out, okay, considering there is nothing else that exists, because of course, in a normal setup, this invoice is just one piece out of many pieces that represents a workplace. So just from this limited information, what can I do? And that sort of kind of sometimes can make things difficult because you're not looking at the complete information, you're looking at partial information. I don't know if that makes sense to you guys or not, what I'm saying.
No, it does. It really does. Absolutely. I feel like trying to look at a piece of it and trying to figure out the bigger picture is tougher for sure. So
Yeah, and for like more we do it, more we'll learn, right?
Right, exactly. So that's what I'm saying, even I was like thinking, okay, when I was converting, I was putting together the first normal form. Then the art code is something that is not there, but thinking like, I wouldn't maybe want to have that in case if the customer comes back, I want to make a purchase again. And if that is not there, then the system will fail and will tell oh, too bad, you cannot purchase because you already purchased this art piece. And then the person sitting at the cash register would be like, you know what? The only way around would be that we create another customer account for you. You know how bad it'll look like? It's like,
Right. So in a way, it's like anticipating the needs. Maybe if we like look at it that way, anticipating the needs and why they would have to be broken down separately, maybe that'll help.
exactly. That's all, you know, I mean, that's basically what the designer is thinking about things ahead of time and looking at the data set and like, okay, what possible outcomes could be there? And then based on that, because again, you know, when systems analysts do the designing, the outcomes are also in the data dictionary. So when the designer is looking at the data dictionary, sees the possible outcomes and then designs accordingly. So you probably get to see the bigger picture, the real world picture, of course, when you are in such a setup. And how likely it is for all of you to run into that situation, I don't know. Not everybody will run into that situation. Not each and everyone would ever run into that situation. You may probably retire and would have never done normalization. That's quite possible. But at least you'll have exposure to it. It's as to what it is, if you ever want to run into that. But again, remember, it's a specialized field. It's just not like every database programmer doesn't do normalization, but does every database programmer needs to understand normalization? Yes. Anyway, moving on to that second normal form, that I was able to remove partial dependencies from customer art table because some fields were dependent on art code and some fields were dependent on customer art. Now comes a third normal form. In the third normal form, again, you know, I will probably, you know what, I'm better off dividing this up into multiple fields because that's how it is over here. The customer address is basically street, city, customer province, customer postal code, right? Did I miss anything here? It's street, city, province, and postal code, right? Those are the components. Again, some people who have never traveled outside of the US and are a little weaker in geography would be like, what is a province? Because they've seen state systems all their lives. What if your client happened to be in a different country, or members of your team are actually in a different country? Sometimes, you know, you work with outsourced employees or with employees in a different branch of your organization. And sometimes they're not accustomed to things that we are accustomed to. That creates a very different corporate culture. So there's always a learning. That's, you know, there's always a learning. You learn from them, they learn from you, and so on and so forth. Okay. So for example, if you were to create a database for a chef, a pastry chef in the United States versus in France, do you think they will be having somewhat identical infrastructure?
Somewhat, but there are details that you'll need to change for each location.
But usually the bakery business in the US is very similar to the one in Europe because there's a lot of inheritance between the systems. You know, a lot of the chefs actually either got trained over there, or they have been globally, there have been so much exchange of information and training that you will find a lot of similarities. You won't have a big difference in transitioning to building an application for somebody in Western Europe, for example, as compared to US. There's a very smoother transition. But let's say if you were to do it for somebody in Africa or somebody in China, when was the last time, I mean, like, have you ever seen a Chinese bakery? I've never even seen a Chinese bread.
Yeah, I don't think I've seen it.
I have no idea even if they have bakeries. If they do, what kind of bakeries they have. So if there's a national corporation in China based, and you would have to go and do something for them, you probably would have to learn a lot of things before you can do something for them. So again, I mean, I don't know. So let's have a look at third normal form here. So the customer number and everything else about customer is only dependent on customer. So there is no transitive dependency here. We could just leave it as it is. Customer art is also pretty straightforward because price is dependent on all three factors. Now come art. Art, is it okay, or does it need any further breakdown? Does art has any transitive dependency? Means partial dependency?
So what does that actually mean?
What does that actually mean is this: are all the fields completely dependent on the primary key, or are there any fields that are dependent on a different field which is dependent on the primary key?
The name is dependent on the ID.
Yeah, so name of the artist has nothing to do with the art code. Okay, so we can easily separate that piece of information out into two sets of table that I could create an art table and I could create an artist table. And in the art table, I could put the art code. I could use artist ID as the foreign key. So let me italicize that. And then I could have an art title. That'll be a regular field. Okay. On the contrary, in the artist, I'll have the artist ID, which will be a unique representation of every artist. So it's going to be a primary key. And then I will have the artist name. Okay. Now, if I go back and let's start looking at the artist name, if you notice, all the artists have first and the last name. So if I really want to save it, depending on how they query. So if they really want the artists to be able to be queried on their first and the last names, I could then further break it down that way as well.
Yeah, we got as far as thinking about the art and the artist, tables needing to be separated, but yeah, we kind of we were thinking about it while we were still in 2NF and didn't quite get there, but yeah.
So you don't need the art price for the art?
I don't need what?
You don't need the price for the art?
Here it is.
Yeah, but that's in the customer art, right?
Because that's what the pricing is. Because I could be selling the same art at different prices at
Oh,
different
okay.
times of the year.
Okay, that makes sense. Well, I guess it's getting better.
And, I mean, think about it. Where were you when you did the exercise 1 and where you are when you're doing exercise 3? And that's a transition that you look at just in 3 examples. You know what I'm saying?
Yeah, I agree entirely.
Yeah, that's fair.
Okay, so 1 second. Um, so nobody needs this, right?
Maybe. Maybe, honestly.
Just took one. I'm just kidding.
Well, you know what? I got a better deal for you. How about you take this one?
That's much better. Yes, good call.
And then you can have lots of Z's from NyQuil. Anyway, so let me close the breakout rooms. And go to the chapter 3 summary on page number 16 and read the chapter summary. Page 16 of the PDF or your book. Your book probably should be a different page number, but towards the end of the chapter 3. Yeah. That will be page 66. Okay, so Desmond and Francisco and Tony and Jack. Still reading summary. Okay, guys. So as you can see on my screen here that I am sharing with you, that's chapter number 4, physical database design, creating tables. We're gonna briefly look at like some of the topics in chapter 4. We will continue with the other half of chapter 4, along with chapter 5 next week. But chapter 4 pretty much starts going into the physical database design, where you start deploying the databases in physical terms. So that's where the author is explaining you what physical database design is, explaining to you what is a database management system, and he's explaining the hierarchy of databases, tables, rows, and columns, and explaining the EBCDIC representation for storing the data. And the rest of it is pretty much about schema and tables and all of that other stuff that we'll look at next time. So what exactly is a database design, which is a physical design? It's basically a bridge between the conceptual data modeling and its actual implementation. So in this stage of application development, this is where you need to determine the actual hardware and the software system on which your design will be deployed. So for example, if somebody is using Oracle, and in the design phase, you came up with, in the earlier design phase, you came up with a data type called character to store somebody's first name. When you translate that into the physical design, forget about Oracle now, let's talk about DB2. So when you translate the first name into DB2 physical model, will you use character data type or will you use variable character data type?
Variable character.
Variable character data type. And that is very DB2-like implementation, because variable character means that you have a maximum size. However, within that maximum size, the data will vary. However, if you are taking your logical design to Oracle, then you can't even choose variable character, because Oracle doesn't really have a varchar as a data type. It rather has what Oracle did many years ago. They created a variable character data type, but they kept it for research. So what they did, what they took into the actual implementation of a physical database was a data type called varchar2 with the number 2. So if somebody is taking the logical design, the conceptual design into a physical design for Oracle, then they will actually be going for varchar2 versus varchar. If you're going to some other databases that give you a luxury of having a text, doesn't give you a luxury of a varchar, then you will go and choose text. So I mean, like, depending on the underlying implementation is what you will be going with. So conceptual data modeling analyzes an organization's information requirements to produce a data model that specifies entity types, attributes of entities, relationships, and integrity rules. And this conceptual data modeling terminology is mapped to the physical design. And this is the actual physical to entity relationship diagram. What you call entity in the ER diagram is actually the physical table. It's called table in the physical design. What you call instance is called row. What you call attribute is called column. what you call unique identifiers called the primary key. What was your secondary unique identifier is now the unique key. What your relationship was, now it's called a foreign key. What your business rules were is now called a check constraint. So when we start coding SQL, that's when you start to see all these different kinds of keys. Again, these keys are non-existent for somebody who is in the conceptual phase or somebody who is in the logical phase. So you may be like, okay, then what is the difference between a unique key and the primary key? It's the same difference it is between social security number and your student ID. Social security number is also a unique identifier that uniquely identifies you at Gateway Technical College, and so is your student ID number. The student ID number is at the forefront because for security reasons, you do not want to be going around telling everybody your social security number. You know, you go to the registrar's office, they're like, okay, what's your ID? And you tell social security number, and like, or you're writing down your social security number on a piece of paper and handing it over to them. And if the paper gets mishandled, because when you fill out an application form for anything after you become a student, you put your ID number. Think about putting your social security number. Now your social security number is going around all over the college. Your instructor will know your social security number. Everybody will know your social security number. That'll be a risk, a great risk. So you would rather keep that as a unique identifier to uniquely identify you as an individual for other purposes, for office use, and use your student ID at the forefront. Now comes another issue with social security being the primary key, especially in a college setup. Everybody who comes to Gateway College doesn't have a social security. And why?
Some of them are on visas.
Some of them are foreign students. They don't have a social security number. They have other forms of identification, but not social security number. So their identification then becomes the identifier, the secondary identifier. So in most cases, with foreign students, we take their passport numbers. So their passport numbers are unique, and that become their identifier until they get a social security number, and then they could replace that with a social security number, but that would be their unique identifier. Anyway, so, and that's what basically this table pretty much tells you. Transforming conceptual design to physical design. For a table, the following design information should be specified. We're talking about in terms of the physical implementation. So we need to come up with a full table name. In DB2, the table names can be more than 10 characters long. But to the operating system, an object name cannot be more than 10 characters long. So what really happens behind the scene? If the name of the table is longer than 10 characters, then the operating system creates a short name and a long name. The short name is what you would probably use with RPG, for example, because RPG also doesn't understand longer than 10 character names. But for languages like Java, C#, they could interact with full table name. So that's why the system will create two names for names that are longer than 10 characters. The name of the entity in the related data model, the descriptive text that represents the table, the schema in which the table will go, and user profile that will own the table. So because you know that user profiles have schema, and you can have multiple schemas under the same user profile. A schema is basically a placeholder like a library. So schema is equivalent to a library. Just like a user profile can own multiple libraries, exactly the same way a user profile can own multiple schemas. So at this level, you're pretty much saying that which schema, which is equivalent of library in the database, this will go. So that's what basically is going on here. And then for each column, you need to come up with the column name. And column names are identical to attributes. Table name should also be mentioned because this column will go into some table. So which table does it belongs to? Descriptive text for the column in case if you want to describe what this column will store, what kind of information will be there. Some kind of a reference to the name of a standard column data type. default column heading, if there needs to be one, column data type, length, decimal positions if needed, whether the null placeholder is allowed or not. For example, if it's a required field, then the null placeholder should be off. So you need to mention if it's a required field or an optional field, if there is a default value, if there is any, and default display and print formats, as for example, for telephone number, what format are you using? So that accordingly, the format masking can be done at a later stage when somebody is doing the user interface design. Okay, before I go to the primary candidate and foreign keys, I want you to read everything on pages 3 and 4 and right above the primary candidate key. So if you are looking at your actual book, that would be pages 71, 72, and 73. 71, 72, and 73. And on the PDF, it is pages 4 through 6, right? Yeah, no, it's 3, sorry, 3 through 5. My bad. It's 3 through 5 of PDF. And give me a green check when you guys are done. So Victor, Jack Lear, Devin, Francisco, and Luke. If you guys are done, you can hit the check. If you are not done, then whenever you're done, you can hit the green check. Okay, the next topic on page number 5 of the PDF is primary, candidate, and foreign keys. As we have learned in the previous chapters, that primary key is the key that is used to uniquely identify every record. Foreign key is used in relationships when you want to link one table with another table. What is a candidate key? Candidate keys are those keys which are initially picked as one of them will be promoted to the primary key, and the rest of them could either become a unique key or other sets of identifiers, which at a later stage, the database developer could then promote them to index keys, non-primary key index keys, which we'll talk more about when we talk about the indexes. So create table command is the database command, which is used to create a table. It's actually the create is the command, followed by the type of the object you want to create. So if I'm creating a user, it's going to be create user. If I'm creating a trigger, it's going to be create trigger. If I'm creating a view, it's going to be create view. So initially, you will see a lot of create table commands. And then view is, it's like logical files. Okay. So now here it talks about specify a view implementation. Once the initial database design for the data models table is complete, it is time to specify how the database will provide for the necessary end users views. Recall that end users may need to see only selected rows or columns from data that is stored in tables. So users also may need to see data from several tables combined in a view. So view is like a logical file, and a logical file give you only a limited access to a table's data or a limited access to or limited data set from more than one tables as well. So you could do a join, like a logical file was a join between several physical files, or could be a look into some of the rows or some of the columns of a physical file. So views are exactly the same way. Why would you want to have a view? Of course, so that you can give only the needed access to the people who need it. You don't want to expose your entire data set. So that's basically what view is. It's an equivalent of logical file in the databases, and it is created with the help of the create view command. Specifying security implementation. So the first step is to specify public and private or individual user profile authority. For you guys, it's already done. Or wherever you go in the IBM shop, the IBM iOS security officer will do that for you. The grant statement or the grant object authority command then can be used to grant authorities. For example, you created a table. And for example, Josh created a table, and Josh wants to share the table with Cole. But Josh only wants Cole to be able to see the data, not be able to change the data. So Josh will only grant select permission to Cole. So Cole will be able to see all the data in the table, but won't be able to modify it, won't be able to delete it. Similarly, Josh works with Jack on the same project. And since Josh is the owner of the table and Jack wants to do data entry into the table, so Josh would give Jack an insert operation permission. And as soon as Jack is done, the Jack will notify Josh, I'm done with all my data entry. So then Josh can revoke the permission from Jack. So that's basically what you do in grant and revoke authorities. That's all part of the security deal, security specifications. And then you can specify additional indexes. As I was telling earlier, that your candidate keys could serve as additional indexes. For example, if you're creating a bookstore database, Now, books are very rarely searched by ISBN number. Most of the time, they're searched by title. Or sometimes, if it's a very famous author, by author name. So ISBN number is the primary key of the table, but because the books are searched mainly by title, you would also want the title to be an index field. Not a primary key, but an index field. Now, what exactly does an index do? It does the same thing as the index does in a book. What is the purpose of an index in the book?
Help you find things.
Faster, right? That's exactly what an index do in a table, that it creates a separate way to access the same record set besides the primary key. So anytime you query the table based on an indexed field, then the database intelligently goes to that index and say, okay, quickly find the title, and then it locates the data and then gives it to you. Have you ever seen a book with multiple indexes?
Once, it was in a textbook for, like the regular index, and then there was an index for the footnotes specifically.
Yeah, see? Similarly, I used to teach mathematics for trades. So at the back of the book, there were two indexes. One was a regular index, and the other one was a trades index. So what the trades index did, it would list a trade, and then will list all the pages in the book where there are problems related to that trade. So when I had welding students, I want them to solve more welding problems. So I could go towards the end of the book and I can say, okay, which chapters have welding problems? So I want to make sure that when I'm covering those chapters, I wanted to make sure that I do the welding problems with these guys because they will be welders. So that kind of stuff. So that basically adds to the performance. However, if you have too many indexes, it slows down the searches. Okay, so now what I would like you guys to do is I want you to read pages 5 through 8 for your books, pages 73 through 77. Okay, so Francisco, Jack. Okay, cool. Everybody got it. Okay. So guys, you know what? We're going to stop here today. We're going to continue on from hierarchy of data because, you know, Josh is telling me I'm tired. Don't go any further. You know, I got to respect
You
that.
got it. Ready to go. Wrap it up.
Okay, so
We already took the Advil PM, so
say it again.
we already took the Advil PM. It's time for bed.
So guys, I have removed the assignment from this week. So because it requires some SQL. So the only thing that I would want you guys to do during the week is the review one. That's the only thing that's assigned to you besides reading. And if you have not done assignment number 1, make sure you complete that. And that should be all for tonight. Oh, there is one extra thing Desmond has to do, but it's only for Desmond. Desmond, don't forget to hit the gym.
You funny.
You said we have to do review 1.
Yeah.
Right? Not review 2. Okay.
No. Yeah. Review 1. Exactly. Just the review 1.
Okay. Perfect. Thank you.
Yeah. And Desmond, don't hit the wrong gym. I'm saying this gym and not that gym.
I got you.
Okay. Otherwise, you're going to hit Jim and say, you know, Saad asked me to hit Jim.
But what if he deserves it?
Oh, he deserves it.
I don't know who deserves what. But well, you guys take care and I'll see you guys tomorrow night. Oh,
Yeah, have a good night.
you do. Take care. Bye.
Have a
Thank
good
you.
night.
Have a good night.
See you tomorrow.
So.